Good morning, students. Previous classes we have learned about chapter 5, magnetism and electromagnetism. What is magnetic field? Then magnetic lines of force. Then Fleming's left-hand rule. This is everything previous classes we have learned. I am thinking you all learned well. Okay. Once again I am repeating Fleming's left-hand rule. See, stretch 3 fingers. So what are the fingers? The thumb, second finger and middle finger. You can say forefinger or second finger and middle finger. So the thumb, middle finger indicates, what is that? Indicates the direction of current. And the second finger indicates the direction of magnetic field. And thumb indicates the direction of motion of a conductor. Now, today we can learn about electric motor. So electric motor or DC motor. DC motor means also you have to write electric motor. Now, what is the use of this electric motor? What electric motor converts into electrical energy into mechanical energy. Electrical energy into mechanical energy. See, electric motor converts electrical energy into mechanical energy. Electric motor converts electric energy into mechanical energy. Can you say where the electric motors are used? We are using daily in our life. We are using so many electrical appliances. No, in that fan, they are using electric motor. Then washing machine, mixie, grinder. So everywhere electric motors are used. Today we are going to learn about what is the construction and working of the electric motor or DC motor. Okay? Electric motor or DC motor construction working we can learn. And see, first point, electric motor converts electrical energy into mechanical energy. So the electric motor is where it is used means it is used fan, washing machine, mixie and grinder. Okay. So now we are going to learn about what are the construction working of the electric motor. Before that we have to draw a diagram of electric motor. Very important question. So you have to learn what is the diagram of electric motor. I am drawing on the blackboard. Just listen carefully and you have to mark the parts also. After that we can see the construction working of the electric motor. Now it consists of a permanent magnet. Permanent magnet. This N and here's the poles of a magnet. Permanent magnet. So just you have to write here permanent magnet. So already we have learned permanent magnet. What is the permanent magnet? It does not lose the magnetic power. Okay. So it consists of two poles. You know what are the two poles? North pole and south pole of a permanent magnet. In between the magnet, we have to attach a rectangular coil of wire. What is this? Rectangular shape. No, rectangular shape. So rectangular coil of wire. We have to use the rectangular coil of wire. So first permanent magnet. So we can mark this rectangular coil of wire. So first permanent magnet, next one rectangular coil of wire. At the end of the rectangular coil, a commutator is attached. Commutator. So commutator. So what is the use of this commutator means to change the direction of a current. To change the direction of a current. carbon brushes. Carbon brush. This B1 and this B2. Now at the two ends of the carbon brushes, external circuits are attached. Is battery and resistor, variable resistor. So these are the diagram of electric motor. See, first you have to draw the diagram, then you have to mark the parts. See, first this, what is this? Permanent magnet. In between the two poles of a permanent magnet, what on attached? Rectangular coil of wire. So here at the middle of the coil, this axle. So by using this axle, the rectangular coil of wire will rotate. Now just write here rectangular coil of wire. At the end of the rectangular coil of wire, what is attached? Commutator is attached. What is the use of this commutator? To change the direction of current. Now here carbon brushes B1 and B2 are attached. Through that brushes external circuits are attached. The external circuit, battery and variable resistor. Now these are the construction of the electric motor. So now you know how to draw the diagram and what are the constructions of electric motor. Now how it work? We can see how the electric motor will work. Now it consists of 2 amps. See, one is A, B, next C, D. 2 amps, 1 amp is AB and the second one CD or DC. Now, when the current, you all know from the positive terminal of the battery only current will flow through this conductor. No. So, when the current flows through this conductor through B1 and through this coil A and the amp A and B. So, the current direction like this. Next, the current passes through C and B. See the two direction, just opposite. No, the current passes AB and CD. Then through this. See, first it will rotate clockwise direction. First it will rotate clockwise direction. After that it will change anti-clockwise direction. So first which direction? Clockwise direction. And next it will change as anti-clockwise direction. Now the current flows through A towards B. Now the current flows A towards B means the force of the conductor will act opposite direction, downward. The force act downward. The current flows through upward. What happens? The force of a conductor will act downward. Here the current flows downward. The force of the conductor will act upward. Okay. Because of the force of the conductor only, the coil will rotate. Now first how it will rotate? A, B, C, D. Now the current flows through A, B, C, D. Which direction? Clockwise direction. After that, what is the use of this commutator? To change the direction of current. By using this commutator, it will rotate now. So this shape and then what happens? The CD amps will come up and the AB amp will go down. So after that, what happened? It will rotate. Which direction? Anti-clockwise direction. So that then the current flows DC. Okay, the current flows DC. Like that, the rotation will happen in this electric motor. Okay, can you understand what is the construction and the working of the electric motor? First, you have to draw the diagram and mark the parts. Then construction and working of the conductor. See here, when the current flows through the conductor, normal to the magnetic field. It's act normal to the. Normal means perpendicular to the magnetic field. Always the current flows this direction. The magnetic field perpendicular to this current. Okay, that time the poles of the conductor, the force of the, because of the force of the conductor only, what happened? This rectangular coil of wire. Okay. First, which direction it will rotate? Clockwise direction. After that, anti-clockwise direction. First cycle, clockwise direction. Next, anti-clockwise direction. Next also clockwise direction, anti-clockwise direction. So like that it is going on. Then how the speed of the conductor will change. See that 4 points are there. First point, increase the strength of the current. Increase the strength of the current in the coil. Okay. First point was how to change the speed of the conductor. So speed of the rectangular coil. Now see first point, increase the strength of the current. Second point, increase the area. Second point, increase the area of the coil. First, increase the strength of the current of the coil. Next one, increase the area of the coil. Next one, increase the strength of the magnetic field. Strength of the magnetic field. See, first increase the strength of the current. Second one, increase the area of the coil. Third one, increase the strength of the magnetic field. Next one is increase the number of turns of the coil. Okay, number of turns of the coil. Increase the number of turns of the coil. Because of this four reasons. So next increase the number of turns of the coil. So increase the number of turns of coil. Because there's four reasons, the coil will rotate very speed. Okay, so this about the electric motor. So can you understand, students? So the electric motor converts electric energy from this name itself. You can write here electric. So electrical energy into here M into mechanical energy. So the electric motor converts electrical energy into mechanical energy. So where it is used? It is used in fan, washing machine, mixie and grinder. So you can write then what principle here used? What is the principle used? When the current flows through a conductor. Okay, when the current flows through a conductor, what happens? The force act on the conductor. Because of the force only, what happens? It will rotate. Which will rotate? The conductor will, the coil will rotate. So that principally used in this electric motor. After that, just to draw the diagram. I'm thinking all the students know to draw the diagram. So you have to draw the diagram. Mark the parts. Very, very important. Mark the parts. Your book by question is the what are the parts of the electric motor. So you have to draw this diagram and to mark the parts. Okay, this much parts you mark it. Here this external circuit. Just you can mark this as external circuit. First one, permanent magnet, rectangular coil of wire, commutator, carbon brushes and this external circuit. So this much you have to mark it. Then construction and working of the electric. Next one is Faraday's experiment. Faraday's experiment. So Faraday's experiment only you have to learn electromagnetic induction. See, electromagnetic induction means, suppose this is the coil of wire. Here coil of wire and here magnet is there. Magnet, the north pole or south pole. Magnet is there. There is coil of wire and magnet. So this area it says a magnetic flux. When the magnetic flux linked with the coil, when the magnetic flux linked with the coil, the EMF will produce. This induced EMF is called electromagnetic induction. So coil and the magnet. So the magnetic flux, this area will say as a magnetic flux. So magnetic flux linked with the coil changes, EMF will produce. EMF means what? Electromotive force. EMF will produce. This induced EMF is called electromagnetic induction. So all of you know electromagnetic induction. So the coil is there, magnet is there. So in between only what is that? Magnetic flux. The magnetic flux linked with the coil, the EMF will produce. This induced EMF is called electromagnetic induction. So you know about electromagnetic induction. So the Faraday's experiment, he explained the electromagnetic induction. For that, 3 experiments. He has given 3 experiments. So first one, first coil. We are using the coil. First coil and this one second coil. See the first coil, it is attached galvanometer. So Forward means when the current passes through this conductor, this galvanometer will shows deflection. For that only galvanometer is attached. So here battery and resistance. Now the circuit is closed. The switch. Now the circuit is closed. Now listen, the circuit is closed. When the current flows through this conductor, what happen? It will show. So when the switch on, the current flows through this conductor and the galvanometer will show deflection. Deflection means what? It has needle and needle will show the deflection. It will move here and there. That's why deflection. Galvanometer shows deflection. So that way we can identify when the current flows through this conductor. When the switch off, it does not pass, the current does not pass the conductor, the deflection will go opposite side. So here current produced means the deflection will increase, and the current, there is no current means what happens, the deflection will come at zero. So just the opposite side. This is the first experiment. From this he concluded that when the magnetic flux linked with the coil, that's the EMF will produce. The first experiment. Look at this picture. Here magnet is there and they are applying voltage. In this experiment, the current is generated by the movement of the magnet in and out of the coil. The greater the number of turns, the higher in the voltage generated. How many turns are there, that much the voltage also generated. This second experiment. Now look at the third experiment. Look at this picture. Here magnet and this is the coil, and here the galvanometer is attached. The magnet is stationary. Stationary means does not move anywhere. Stationary, but the coil is moved in the out of the magnetic field. Hence the current is induced. So here when the magnet, if we keep stationary, the coil, it will move here and there. So from this experiment we can conclude the electromagnetic induction. So what is electromagnetic induction? When the magnetic flux, here only magnetic flux is there. When the magnetic flux linked with the coil changes, EMF will produced. The induced EMF is called electromagnetic induction. So from this three experiment we can conclude that the electromagnetic induction. So next one, Fleming's right hand rule. Stretch 3. First left hand rule we have learned last class. Now the Fleming's left hand rule. Here also stretch 3 finger, thumb finger, 4 finger and middle finger. What are the 3 fingers? Thumb finger, 4 finger and middle finger. Okay. 3 also mutually perpendicular to each other. So 3 finger also mutually perpendicular to each other. Now the middle finger shows the direction of induced current. Their current we studied, but here induced current. The middle finger indicates the direction of direction of induced current. 4 finger indicates the direction of magnetic field, and the thumb indicates the direction of motion of a conductor. Okay. First stretch 3 finger. What are the finger? Middle finger, 4 finger and thumb. 3 also mutually perpendicular to each other, and the middle finger shows the direction of induced current, and the 4 finger shows the direction of magnetic field, and the thumb shows the direction of motion of the conductor. So these are the Fleming's right hand rule. So last class we have learned left hand rule. What difference you have find out? There also stretch 3 finger, here also stretch 3 finger. But here right hand rule, the middle finger shows the direction of induced current, but here the middle finger shows the direction of current. Here current, here induced current. So that really difference. Fleming's right hand rule, this Fleming's left hand rule. Okay. So today we have learned about electric motor and Faraday's experiment and Fleming's right hand rule. So take your book, students. We can mark the question. Rome letter 5, question number 3. List the main parts of the electric motor. Page number 58. The diagram given. Just to draw the diagram and mark the parts. Parts also given. Just you have to mark the parts. Next, eighth question. State Faraday's law of electromagnetic induction. Page number 59. Faraday conclude that whenever there is change in the magnetic flux linked with a coil uh, linked with a closed circuit, an EMF is produced. This induced EMF is called electromagnetic induction. This induced EMF is known as electromagnetic induction. Next, Rome letter 6, first question. Explain the principal construction working of a DC motor. Electric motor, page number 58. First, you have to write an electric motor is a device which converts electric energy into mechanical energy. Next, principle. When the electric current is passed through a conductor placed in a magnetic field, a force acting in the conductor and this force make the conductor to move. Next, you have to draw this diagram. Then, here given from here to a simple coil is placed inside the two poles of a magnet. The current carrying conductor, the segment AB, the direction of the current is towards B, whereas in the conductor segment CD, the direction is opposite. As the current flowing in opposite direction in the segment AB and CD. This much. The next construction working. The current flow in along the line ABCD, then the coil will rotate in the clockwise direction first and then in anti-clockwise direction. Next, the direction of the current should be along ABCD in the first half of the rotation and along DCBA in the second half of the rotation. To change the direction of current, a small device called the split ring commutator is used. So dear students, today we have learned about electric motor, Faraday's experiment, electromagnetic induction. Just you have to learn electric motor. You have to draw the diagram and the construction or principle. You have to write the construction and the working of the electric motor. Next day assignment, this question, electric motor. You have to study and write in that same booklet. Then last class I have given 3 assignment. I have given small questions. I have given. Just I am thinking you have study and written. I am thinking just this also. Next day the one question detail answer, construction principle and construction working of a electric motor. Study well and try, students. Thank you.